Low Voltage Breaker Course Section 9. The Heavy Duty Breaker, Air Circuit Breakers, ACB. Main feeders in large buildings. Welcome to Section 9. We started with the miniature breaker and scaled up to the mold case breaker. Now, we reach the pinnacle of low voltage protection, the ACB, or air circuit breaker. Highest current capacity. ACBs are built for the highest currents in the low voltage world, typically starting where MCCBs leave off, around 630 amps, and extending up to a massive 6,300 amps. They handle the main incoming power feeds for large facilities. Robust construction for performance. These breakers are complex, modular devices designed for high-frequency operation and superior durability. They are generally much larger than MCCBs and are essential components of main switchgear and large distribution boards. The name, air arc extinction. The air in air circuit breaker refers to its method of interrupting large fault currents. When the contacts open under fault conditions, a powerful electrical arc is drawn. The ACB uses the surrounding ambient air, often compressed or forced, to rapidly cool, stretch, and extinguish this arc inside specialized arc chutes. Essential for main protection. ACBs serve as the main, primary level of protection for an entire building, factory, or commercial campus. Their failure is not an option, making their reliability and high car rating absolutely paramount. Draw-out mechanism. A key feature unique to large ACBs is the draw-out mechanism. This allows the entire breaker unit to be safely disconnected from the main bus bars and mechanically slid out of its enclosure cubicle while the main system remains energized. Safety during maintenance. The draw-out design is a huge advantage for safety and maintenance. It means a technician can safely perform inspection, repair, or replacement of the breaker outside the live switchgear, drastically reducing maintenance downtime and risk. Advanced electronic trip units. ACBs almost always utilize highly sophisticated electronic trip units. These units offer maximum adjustability for the time delay, short time, and instantaneous trip settings, crucial for complex selective coordination strategies. Communication and monitoring. Modern ACBs often include advanced communication capabilities. They can integrate into a building's monitoring system, providing real-time data on energy consumption, current draw, and fault history to facility managers. ACBs versus vacuum SF6 breakers. While ACBs dominate the main low-voltage distribution, it's worth noting that for medium voltage, $GE1000V, other technologies like vacuum and $text, SF_6, sulfur hexafluoride, breakers are used to safely interrupt much higher energy arcs. The unsung guardian. The ACB is the unseen giant of electrical protection, handling the largest power flows and ensuring stability for the entire downstream system of MCCBs and MCBs. Up next, decoding the label. We have covered all the major low-voltage breaker types. Before we talk about selection, our next vital step is learning how to read the most important numbers, understanding breaker ratings on the nameplate.